Let's discuss question number 43. This is from test 5 from strength of materials. A machine part is subjected to eccentric pull of 100 kilonewtons. The normal stress at B. Okay, so you have a bent pipe, something like this, and you are applying 100 kilonewtons on both sides. So if it would have been a straight pipe, then you just have the axial stress, but here there is some bending. A, B, and the distances are given. This is 50 mm. The dia is 100 mm, and what is asked is the stress at B. Okay, so before doing this, let's understand some basic thing. If you have a body and you are applying a force P, this is just equal to the same load P, and at some other point of interest I can just let me apply P and P in this way. So this is the 1 and 2's are all same, right? Both you have the net force P in this direction. Now I can consider this and this to be a parallel force equal in magnitude but opposite in direction. So these two form a couple, and that couple is P into the distance. Okay, so that is the couple which I am denoting by M at this point, and you have the force P. So basically what it means is any load at a point can be considered as a load at another point with a couple, but the couple value is, if the distance is E, so M would be P into V. So any load can be considered as at another point the same load plus the couple. Okay, so both are in force equilibrium or static equilibrium. So what we will do is, just to understand this load I can consider as a load here, and the couple exerted by this 100 about at this center would be 100 into, so the couple will be like this, right? Or you can say the effect of this 100 will be at this section a pull and a moment which is something like this. So this moment would be the center of AB is, because the dia is 100, so this is the center from B with 50, and B is always is 50 from the axis, so the total is 100 mm. So the moment will be this 100 kilonewton, that is 10 power 3, into this eccentricity which is 100 into 10 power 3. So this is your E value, so that is 100 mm. Let's keep it in Newton mm. So this is 10 power 7 Newton mm. That is your moment. So now you have the load P. So at the section AB, this section should support load P as well as the moment M. Now because of the load P, you have tensile stress over this section, and because of the moment M which is supported by this section, this moment is the, if you take a cross section and balance the right hand side or the left hand side, you will understand that this moment is the bending moment, and that produces the tensile here. Okay, so you have the stress at B is due to the axial load which is tensile in nature, plus due to your bending moment, and this is also tensile in nature at B. At A it is compressive, but we are asked at B, so it will just add. So due to load P will be, for the entire cross section it will be P by A, plus due to bending moment it's M by I sigma by Y, so it will be M Y by I. So now let's substitute the values. Only important thing is both will add because both have the tensile nature. Load P is 100 kilonewton, so 100 into 10 power 3. Area is pi by 4 d square, that is 100 whole square, plus moment is 10 power 7 Newton mm. Distance Y is diameter by 2, which is 50. Cross section I for a circular cross section is pi by 64 d power 4, which is 100 power 4. So this, if you add, you get a value which is So let's do it. So 50 mm, be careful with the unit. So this value comes out to 114.59 Newton per mm square, that is MPa. So 114.6 MPa. So the answer is C. So only important thing is just understand what is the nature, what is the load that is coming on that section. The load due to this P is the effect of this P at this will be the load P and the moment M, and so that moment creates tensile, or basically you can just, when you are applying load like this, it has a tendency at this section, at B it tries to open up, at A it tries to close. So at B the effect of moment is tensile, due to load it's all tensile. So you have, these are combined case of axial plus bending. So 114.C, answer is C. Thank you.